and welcome to our webinar hosted by TDS Technology. I'm Angela, your MC for today, and we are very glad to have you here with us at Robotics Polishing Made Easy. So let me touch on the admin matters before we go into the presentations by our three speakers. So we'll be doing recording for this webinar, so please do note that if you continue here, we might be using this recording for promotional, publicity, or other similar purposes. So if you have any questions at any time, you can enter your questions in the chat window, and our speakers will address to your questions. So do stay tuned all the way until the end of the webinar because we're going to have a very fun game, Kahoot game, at the end of the presentations. And if you join in play, you will stand to win $50 Grab food voucher, which you can deliver food to your house when you work from home. So we are very honored today to have with us three speakers, Max from Pushcorp Incorporated, Hyok from ZIMMER Group, and James from Robotmaster. So I will hand over to Paul now to do an introduction on our speakers and also to kickstart today's session. Over to you now, Paul.
Okay, Angela, thank you. Okay, I'm very proud that TDS, we have a team of robotic engineers and managed to develop many robotic polishing applications for our valued customers for the last 3 years. By the way, we have only started robotic business in the last 4 years. So company, Singapore Technology, they asked we all to develop a polishing machine for plain engine, remove the epoxy. So we're using the UR10E together with the clipper and with some vision. And second project is form engineering. With 1 year ago, they are doing polishing medical part. After the parts from CNC machine, they need to polish. So they have asked we all to develop the polishing machine. And recently, Bridgeport Technology Private Limited, they are their part is for semicon use, and they need very shining and need very precise control on the force applied on the surface. So we are using Pushcorp for that application, and this project very successful. Customer is very happy. So today, let me share with you, there will be a 3 takeaway. Okay, our first speaker, Max, all the way from America, now it's 10 p.m. Mac Falcon is with Pushcorp, who is globally recognized as a leader in material removal equipment for both tools and parts in hand application. Mac Falcon is with Pushcorp since 2017 and is their VP for Sales and Engineering. So he will share with us how to control the force on the surface. This is very important for product which is need shining and application. So we also have, like what Angela has said, Mr. Joe, he has more than 20 years of experience in mechanical design, and he's from ZIMMER. He's a market leader in clipper and tool change. For polishing application, we need to have more than one clipper or tools. That's why we need ZIMMER tool changers and clipper for polishing application. Last but not least, we also invited James. He's the director of business development. He has 40 years of experience in CAD/CAM and 10 years experience in robotic CAD/CAM. So he will share with us about Robotmaster software for polishing application. The software can generate the path for robot to move so that robot can follow the path to do all the polishing. As what this engineer just now had mentioned, at the end of this three expert presentation, we will play a game. And this is a multiple choice game. For example, we may ask you, push cord is this software. I mean, during the presentation, you will hear a lot of hint. For example, let's say Robot Master latest version, is it version 7, 8, or 9? In the presentation, the speaker will share about all this information. So if any one of you all take part in this game, you will be able to get our ebook on polishing. We will send it to you for those people who take part only. But those people who win the top prize, top score, will get a $50 voucher in cash. We will send it to you. I can see that someone from Thailand and someone from Vietnam, you can use this voucher. Okay, that's all for my opening speech. So I'd like to invite Matt Falcon for his presentation. Mr. Matt, please.
Thank you, Paul. Appreciate that. Glad to hear the PushCorp tools are working well for your polishing project. Hello, everybody. As Paul said, my name is Max Falcone. Let me get my presentation put up here. So I appreciate everybody jumping on here and giving me a little bit of time to talk about polishing. So, of course, let's see here. There we go. So in this discussion, I'm going to talk a little bit about why pursue robotic polishing applications. What's the difference between polishing and buffing? I get this question a lot. And what kinds of equipment is used in these applications? And lastly, I have an application. Who can I talk to? So why follow polishing? Here in the U.S., where I'm based out of, the Deloitte Manufacturing Institute says by 2030, we're going to have a 2.1 million unfilled jobs, essentially creating a giant skill gap. And paramount to this skill gap is going to be in these manual labor jobs that are that require people to be put in big, heavy, dirty, dangerous environment. People just aren't going to want to do those jobs anymore. So why automate polishing with robots? So if you're an end user, like I said, labor shortages due to repetitive, dangerous, dull, dirty work, but also to increase the consistency in the finish from operator to operator, process to process, person to person. Today in a manual operation, you can end up with a lot of variation in your process, where an automated solution will give you a more consistent finish, wear the abrasive less, and overall just be a more efficient process. If you're an integrator, the reality is that these polishing projects, there's less competition out there for these polishing projects, and it's still a growing market as opposed to welding, pick and place, and packaging projects, where those are very diluted markets right now. So polishing versus buffing. What's the difference between polishing and buffing? So generally, polishing, what we're talking about here, is done with abrasive belts and discs. And what you're really trying to do is achieve a desired surface finish. And that surface finish is usually the reduction of pits, scales, and scratches. So you're trying to get that whole entire surface to be consistent. Typically, it's a multi-step process. So you'll start with a coarser grit and end up in a fine grit, and you'll end up with a certain directional scratch pattern within the part. Then buffing complements polishing in that it's generally you're doing two types of buff. You got your cut buff and your finish buff. So your cut buff is turning your scratch pattern that's left from the polishing into a finer scratch pattern, and then your finish buff is bringing out that brilliant shine. So where polishing is typically using abrasives and discs, buffing is usually using pads. Most often it's a cotton pad, but there's also some different foam type pads and different other materials out there that are available for buffing. In addition to the cotton buffs, there's also and many times a compound involved. There are new products out there like Norton St. Gobain's Fab that actually has the compound impregnated into it. So then you just need to use a little bit of lubricant, for example, like water, to achieve your final finish. And like I said, the goal of buffing is typically to achieve a bright, lustrous finish, where polishing, you're just trying to get a consistent finish. And buffing almost always happens after some kind of polishing. So as Paul mentioned in his introduction, here at PushCorp, we make force compliant tooling, and essentially everything we make is dedicated to some type of material removal. So in polishing, we see two different approaches. You either have part in hand, where you are taking a part that you're trying to make, that you're trying to put your finish on, to like a belt sander or a finish stand. So part in hand projects are typically ideal for parts that are easier to manipulate around a tool. So if you have a small part, it's very hard to take a big spindle or big grinder around it, where you can move it around with the robot in much smaller moves. When you're using the part in hand solution, simpler, less expensive compliance devices can be used to apply your force. So typically in a part in hand, you have what's called a passive compliance device. So let's talk about what a compliance device is, and that's what Paul had hinted to. A compliance device is a pneumatic device that PushCorp makes. We make two different flavors, a passive and an active. And typically in a part-in-hand application, you will always use a passive compliance device, because there's not a lot of advantage for the cost delta in an active. The compliance device does have a movable carriage that helps compensate for changes in surfaces, but that movable carriage also helps compensate for the wear in the wheel. And then lastly, when applied, and it's applied when the most consistent finish is desired. So that compliance device will always give you the same amount of force on your process moving forward. So for tool in hand, like this bottom picture where you see the green robot, that's what we call tool in hand, where we're carrying the buffer. This is typically for large parts, large form factor parts that have large curvatures. We would typically use a active compliance device, or in a larger buff, we use the buff wheel as the compliance. The advantage of using the compliance device in a robot mounted solution is being able to compensate for the wear in that buff wheel as well. So here's a couple example videos that I would hopefully will play here. So this here is a polishing project for a stainless steel boat propeller that we were involved in. Here you're seeing the compliance device. If you guys can see my mouse here, this is the compliance device. Like I said, it has a movable carriage. That unit is applying a constant force forward onto that part. And as you can see, with the part in hand, we can handle these unique contours and shapes very easily. The compliance device is able to compensate for the position of the part. And one of the things that's also helps speeds up your process, especially with offline programming, like we're going to hear a little bit, the robot program doesn't have to be exact, because the compliance device is compensating. So if your part varies some, you don't have to do any post-process vision inspection or offset, as long as the part variation is within the stroke of that compliance device. Now here on the other side, you'll see we have a slack belt assembly where we allow the belt to wrap around the part, and we're able to achieve this very high gloss or very high surface repeatability finish on this part. Let's see here. So this is another polish project that we did. This is the lid to a casket. We are running a compliance device with a fixed spindle, and that is a 12-inch flap wheel there, where we are putting a grain finish on the top of this casket lid. When this process is complete, they will paint directly over the surface and the scratch pattern will come through the paint. So what we're trying to do is put a consistent scratch pattern in the lid of this casket here. This is a stamped steel casket. So you can see that, again, the compliance device is compensating for the wheel as well as for the different contours on the part itself. So between the robot, the compliance device, the spindle, and the abrasive media, they're all working in concert to give you a consistent finish. And then finally, these are the front bars to a motorcycle or a moped or a scooter. And I put this in here. This is more of a polish / buff where these parts are already coated. And we are coming through and giving them a brilliant shine. Once again, you have the robot with the compliance device and the spindle all working together to achieve that high gloss buff. But this is an example of a part and tool in hand buffing application. You can see we're doing both the inside and the outside of that part. So just to show a little bit of buffing there. So one slide that I just realized is not in here is what do you do now when you have a application? Well, you would contact TDS and give them an explanation of your information, and together we'll work closely to properly to do the proper application engineering to suggest the right products for your application. So we do have a bit of consignment equipment that we can have for testing that could be done at TDS. Otherwise, we're happy to help with some of that testing in Dallas, Texas. So in summary, the need for automating and polishing applications is growing at a rapid pace. I believe this is true for the whole world, based on the activity that we've been seeing lately. The types of application to automate are the dangerous, dull, and dirty. Essentially, jobs that you really don't want people in because they're going to create a lot of dangerous dust. The parts are big, heavy, and awkward, but also this equipment, you can see the belt sander, the buffing wheels, you get your hand caught one of those, it's pretty dangerous. So we're trying to get people into other activities within the plant that are safer, less repetitive injuries, and give these jobs to the robots. When considering what equipment to use, consider whether it makes sense to have that part in hand or the tool in hand. So this is going to be looking at how many contours in the part, can the robot rotate properly? Is the part easy to pick up with a robot, or is it easier to clamp down to a table and bring the tools to it? And lastly, the compliance devices are really what makes the magic happen because we're able to apply a consistent force on that part at all times. So with the compliance devices, you're able to adjust that force on the fly. So if on a certain part of the part, you only need 5 pounds of force, another part you need 10 pounds of force. It's difficult to do with a robot because in a robot, all you're adjusting is millimeters. With the compliance device, you can actually give it a defined force that you want it to apply, and it'll apply that force. And in the active compliance situation, it can compensate for different orientations and essentially negate gravity. So with that, I thank everybody for your time and your consideration. I thank you, TDS, for inviting me to be part of this presentation. And if there's any questions, I'd be more than happy to answer those. Contact information's right there. Feel free to reach out. Thank you very much.
Thank you very much, Max, for the interesting presentation. And I hope you guys did catch a few of the pointers that Max was trying to stress on, because that will appear in our game later on. So now let's move on to our second speaker. Let's welcome Joe from ZIMMER Group. So Joe, feel free to share your slides at any point in time from now. And of course, for the rest of you, if you have any questions, you can post it in the chat window. Thank you.
Okay, I hope you can see the presentation, the first slide, that everything is working fine.
Yes, we can see. Thank you.
Okay. first, thanks to TDS to invite me for this webinar. I'm Joe, as is already known. I'm in Singapore, based in Singapore, and I'm 7 years with ZIMMER. I will talk a little bit very short about the company only to give a background. Then I will talk about zero clamp systems, how you can use it for machine tending and polishing. Then we talk about gripper for polishing and tool changer, how you can change between parts or also tools. Very short, ZIMMER is a company which is 40 years old. It's family owned. We are more than 1,000 people worldwide. And we started with gripper in the 80s. And the last years, we also do a lot of mechatronic parts like electric gripper and other things, including software. ZIMMER not only offer the parts which I said now, like handling technology, we offer gripper tool changer, something like this. We have damping technology. We have linear clamps for THK, high beam, IKO rails. We do process technology like metal injection molding parts. We do also spindles in higher range, and we do our zero clamps, and we do the last area is system solutions, where we offer complete solutions and not only components. Let's talk about this polishing. We have today PushCorp here. They take care more the tool, and we have Robot Master later. They take care more the software. We look now more on the parts handling, like fixing and holding the parts. As Max said, there are different ways of polishing. You can have the tool moving and the part is fixed, or you can have the tool fixed and the part is moving. I took here the picture of PushCorp finishing stand I found. You saw it in the video too. So one time the part has to be clamped somewhere, the other time the part has to be guided with a robot or by hand along the tool. If we talk now about if the part is fixed, we normally, or many companies still do it manual, with manual loading with a vise, or clamping units like clamping straps, hooks, wedge clamps, or cam screws. Means for your working procedure, you have a machine running time. After this, you have the complete setup of the workpiece time, and then you can run the machine again, because you have to open all devices, you have to bring out the part, you have to take in the part, and you have to fix again. So target could be or should be for many companies to reduce this setup time to a minimum. This we can do with our zero clamp system, which is start or not? Video should start. Okay. This we can do with our zero clamp system. This is a system you see on the left side. It looks like a pot, let's say, with a pin. It's a quite often used system in machining. We have with this system a very high repeatability. We can lock a complete plate or part on a plate in a very precise way. We have a repeatability of 5 micron here. The element is a NC, normally closed element, so it only opens when you give air. It's also in a certain way safe. Zero clamp systems, how we offer it with clamping segments, not only balls inside. So we have here very high forces and moments, and because of the segments, we have a high rigidity. So means at the end we have less vibrations, and especially for polishing or these sensitive working procedures, you get a much better surface. And you see on the picture, on the video on the right side and on the left side, we saw it before with a smaller plate. We can have it as a pellet gripper. We can use this zero clamp for the complete infeed of a pellet, because we can have very high moments and forces, so we can also handle big pellets. In general, zero clamps are normally in stainless steel design, so they can be used in CNC machines or in polishing applications. Each element has a rotation prevention, so you can also only use one element. We call it plus connection to increase the force and the moment of the element. And we have, what is for polishing quite interesting, we have an automatic closing gap. Means if you take out the pin, the dust cannot fall in because there's a cap coming up and close the system. We have these zero clamp systems to change the complete plate are available in 4 and 6 bar, and we have options like blow off and machine part detector inside. Beside this, we can have these complete plates in 2 or 4 or 6 units. So with this system, as you see on the bottom, you can prepare a complete plate with several parts. You can have these plates with 4 units, and then you reduce your setup time of your workpiece significantly, let's say. Because you can prepare this plate during the machine is running, then you only change the plate very fast, and you have additional free machine capacity. So as summary for the zero clamps, we can say this system is interesting for machining because we have a very high repeatability. For push corp, this repeatability is maybe not so important because they can anyway tolerate something, but in general, for CNC machining or something like this, this is very interesting. You save a lot of time during changeover with this system because you simply exchange the plate. So you increase your productivity. The system is an NC element. Even if you drop the pressure, it stays clamped, let's say. And all in all, you save costs. Here, a short help for your Kahoot game, which might be interesting for you later. Okay. So now to the other side, if we have the workpiece, if you have the machine standing, let's say, not on the robot or the polishing tool, and we have to bring the part to the polishing tool. You can do this by manual handling. As Max said, difficult sometimes, especially when it comes to smaller parts, and also a little bit dangerous maybe. If you do automatic handling, like with this finish stand here, and like we also saw in the video before, we need something to hold the workpiece. You can screw it, or you can often also use a gripper to hold the workpiece. This gripper must be sure suitable for dirty and harsh environment. Otherwise, you get problems. We have here an example video of a production in Germany where they use a gripper from the series 5000. This gripper has very high forces, can have high moments. We can have very different sizes from 2.5 millimeter stroke up to 45 millimeter stroke. The gripper in the video has 10 millimeter stroke, so it's a medium size, and I think for these parts perfect. One additional thing is you can have this gripper in strong version, means you have half stroke but double force already. So you have more safety in the holding process. This gripper is available like here on the video in two jaw gripping and 3 jaw concentric gripping. Later we have another video where we have a 3 jaw, and you see here we also go different steps with this gripper through different grinding and polishing steps we go through, and this is an automatic thing which can work 24/7, and also space requirement is here less. This gripper is in standard already an IP64. It can even be IP67 when it's more against water, but IP64 in this case is interesting rating, which allows the gripper to work in this harsh environment like in this video. To reach this IP64, we also use purged air, means we blow air inside the gripper and have a slightly overpressure inside the gripper. So dust or small particles cannot come inside the gripper. That's how we protect the gripper to get spoiled. Here, the application with a 3-jaw gripper for, this is more buffing. And here it's special that we turn the part during we do the operation. So you have the shiny surface continuously around the part, let's say. We grip the part, we have a sensor that we know we grip the part, so we have to bring air and signal through the system, and you see we can turn endless with the last axis. So this, our DWR rotary distributor can do this. We have several air channels and several signal channels to go through and to operate like it's shown here with endless turning. So also a summary for gripping parts during polishing. With our 5000 series, for example, we can have long fingers. We can be far away from the dust. We can have high forces and high moments. Also important because the part should be really hold during polishing. The 5000 series here is available in IP64 version and has a very good sealing, IP67 even against water. And this is because of the use of purged air, where we press out the parts again, let's say, because we have this overpressure. And together with the rotary distributor like the DWR, we can do endless turning applications for round parts. The DWR unit here transfer air and signal. Also again, small help for later. Now, last thing, tool changer to increase your variety of parts or tools. On the left side, the three pictures on the top you saw, these are the parts from the video. In the video, we had a gripper which could pick all these three parts. But what happens if you have different parts like on the bottom, which are really different and you need to change the gripper? Then you need a tool changer. Or you use hand tools like on the right side, different hand tools. So you also have to change the tool. So these are two situations where you need a tool changer. Tool changer are often manual or automatic. Automatic, like here in the video, it's pneumatic control. This is a tool changer for 230 kg payload. We have this also smaller. Our standard sizes go from 20 to 300 kg. And this is sure something where you can also do polishing applications. For heavy stuff, we go up to 1 ton handling things. Here, I took out the example for UR because TDS also is UR partner, so this could be interesting. We have our size 50 tool changer fit direct to UR, to the flange. You not need anything in between, and we have a payload of 30 kg here. And this small, tiny tool changer already has a moment in each direction of 100 Newton meter. So polishing or buffing is not a problem here. We have different energy elements here because, as I showed before with the rotary distributor or also with the gripper itself, you might need sensor signals, or maybe you have some other things where you change the tool changer to another tool where you need some other tools which need simply sensors or something else. So we have a wide range of energy elements which are, and this is interesting, in connected position or in connected status in IP54 already. So also dust is not the main problem here. Sure, if the tool changer is open, dust can fall in. That's the nature of the tool changer. But in connected status, no problem. So as summary for the tool changer here, we have a high payload. Our UR tool changer goes up to 30 kg. We have high moments due to a special design of our locking mechanism. Our tool changer is low in weight, so we have less moments on the robot, and we have many media transfers options like fluid and high power, water-cooled spindles we can bring through, and in coupled version via IP54. At the end, very short, some videos for applications if our standard is not enough. This is our system solution where we do parts up to 1.5 ton. This is the train wheel on the left side. We can handle hot parts. We do machine tending as complete solutions, and we have washing applications as standard. Okay, that's from my side. If more interest, I'm here for questions too. And on our homepage, you can visit our virtual expo where you can see the parts, and you can also go to our system area and watch there our customized solutions. Okay, that's my side.
Thank you very much, Joe, for your presentation. Now we move on to our last speaker for today. So let's welcome James from Robot Master. James, feel free to share your slides. Thank you. We can see your slides now.
Good. Can you hear me also?
Yes, we hear you loud and clear.
Okay, good. First, I'd like to thank Paul and the team at TDS for inviting us to this webinar. Today, I'd like to present one of the factors that have been neglected in the robot market is actual programming of robot polishing. One of the things Robot Master has concentrated on over the last 12 years now is programming robots and then correcting all of the kinematic problems that you might have. And basically, our goal is to eliminate teaching and taking the projects that would take 5-6 days to design and program into the robot manually by teaching, and we do it in rapid time. And our goal is no more teaching. Most of the actual jobs in robot polishing today are done by teaching. And as we did in the beginning when we were using Robot Master, we were importing multi-surface milling paths from CAD/CAM systems, be it Robot Master, Hypermill, the Autodesk 360 programs. We could import all of those programs. And we found that the milling paths, they're not polishing paths. And most of the paths that you receive from other systems, it is very difficult to modify. And you always have to make changes when you're working with your compliance of parts and polishing. And what is even worse, both methods are just outrageously expensive. Teaching is expensive in time and the blocking of the production. And if you're importing the CAD/CAM paths from a milling system, most of those systems start at $15,000 and more. So on top of the price of Robot Master, you'd have to shell out another $15,000 to $20,000. And you can understand the clients, they weren't happy about that when the price of the software was exceeding that of the actual robot. And even though the software can produce more, it was still a very big problem with clients. So we just thought if we have to build it faster, better, and cheaper, so we decided to develop our own software for robot polishing and sanding and spraying. We had done that already for welding and for contouring, and we sell a lot of that. But our biggest market we saw in the future would be in robot polishing, because as Max said in the beginning with his PushCorp presentation, these are neglected markets. No one has really addressed them. So we decided to develop our own program called Robot Master Surfaces, and it's dedicated for polishing, sanding, spraying. So we support all of the polishing wheels or pads. You can also support the RTCP linishing, and we have a special program for the, or they call it tool in hand. We call it remote tool center polishing, and we keep the control point constant. So you have much better polishing results. We can easily create parallel paths. You can easily create morphing paths. We even started now here recently spiral paths. This is a very recent product. We've done this in the last, we've been working on it for over 2 years now. And within the last 6 months, it has just exploded in sales, and it's becoming a large part of it, especially in China. We even do spiral paths because we have a lot of clients requesting that for circular objects, and they don't want to leave a mark at any position. And then here, recently, we've added all of the different paths to eliminate marks on the side while you're polishing. We have trochoidal, sinusoidal paths. I can take any path that we generate inside of Robot Master surfaces and then change the paths to triangular and figure eight. So we have 4 different options within the paths. These are very essential so you won't leave marks on the outside edges. We also give the user a complete control of the position of the pad on the actual polishing product. We can tilt it, we can shift it forward, left or right. You have complete control of the pad. You have complete control of the path also. And at any time, I can go in and modify the path, which if you're bringing these in from other CAD CAM products, you can't do that because you have to take what they give you. We generate it. It's relative to the actual, surface of the object. And from that, we can modify and change the position of the paths at any time. So it's much easier to control your actual polishing paths for compliance. We also work with every robot. It's out there. We do a lot of trimming, polishing, contouring, everything you want. So usually people who are doing sanding and finishing, they're doing other things. They're doing deburring. So you can also do deburring at the same time. And we have our own contouring product. Everything we're doing is designed for robots. It's not milling CAD CAM that's adapted to robots. It is designed for robots. Everything that our clients have asked us, we have adapted now into the product. So you can do polishing tools, and we support the compliant tools. We also do, the product was designed for spray deposition, where you can actually calculate and see the deposition of the material on the product. So it's more than just a polishing product. And then we also do the welding and everything. Let me change here. One thing we allow you, the users, to do is to quickly change everything and modify to the desire of the client. Most of the time you want to do an extension so that the polishing wheel goes beyond the edges. I can go in and change that. And we can also go in and change margins of starting and ending of the actual paths. We'll put this in 10 millimeters since it's a 20 millimeter path. And I can join all the paths with splines at the end, recalculate, apply it. Now everything has a complete spline at the end, joining the paths, and it's one solid path. So at any time, we give you complete control with a very easy menu system, and everything has been designed for polishing, sanding, and spraying. So this is a new product. It's become very high in demand very quickly, and we're quite proud of it. We've spent a lot of time working on it, listening to the input from their clients, and it satisfies the demands of what the polishing people have. And the best part is it's inexpensive. It's not $20,000 or $18,000. So it's in the average about $3,000, which most people are shocked. You have a complete multi-surface CAD CAM program for less than $3,000 that you can add into Robot Master. So this is pretty much what we've done. It's a radical change in the market. And I'd like to thank you all for taking the time to come and watch this. So very quickly and easily, you can polish the product. So that is the end of my quick presentation. But if you guys have any questions, please contact TDS. They have the program now, even though it's new, and they will gladly show you how it can apply. And it's a very good one, working along with the UR robots. We have a large interest from UR clients concerning polishing. So please contact TDS, and they'll take care of you. Thank you very much, Paul.
Thank you very much.